Hey, I'm Minta. Thanks for joining me today. We're going to dive right into exploring how to use the Glif platform. If this is your first time watching a video about Glif, Glif is an app that allows you to combine LLMs, generative image creation, and other interesting tools. But today we're going to focus on how to create a D&D character sheet generator. So I'm just going to dive right in here. This character generator makes really nuanced and detailed character sheets. It's using an LLM and image generation. I'm a longtime DM myself, and being able to quickly generate a full stat block seemed like a lifesaver. So let's get into it. A quick caveat I do want to say, we did have to break this into two parts because it's a little bit of a more complex workflow. So in this part, we're going to discuss how to use the LLMs. To start, click the Build button and begin your new Glif project. For this project in particular, we are going to make a Glif that generates a simple, randomized character sheet for a D&D character based on user input. The first spell or block that we're going to use is a text input. This is what users will see and interact with when the Glif is live. For the first one, we will ask users to provide information about the character that they want, like race, gender, maybe a little flavor to the backstory. We will then add a second text block for the character level. As you can see, these populate to user-filled text boxes to the right-hand side. I'm keeping the level separate because, unlike the first text box, I don't want the LLM to come up with new information. I want it to understand that this is the level the user wants. Next, we need to add some randomizing fields. To do this, we're actually going to leverage a multiple choice tool, which typically is another user input. Normally, this operates as a drop-down list for users to choose from. But if you click the randomize button, it will actually hide it from users, which allows you to leverage random fields and feed them to the LLM. I prepared a list of all the official character races in D&D 5e for this random list using 5e.tools, which you should definitely check out if you haven't before. It's a really cool resource. Next, we're going to repeat that step, but make a drop-down list for classes. Later, we'll actually indicate to the LLM to use these randomized options if the user doesn't choose a race or class themselves. Now it's time to start using the LLMs. We're going to have to pick a text box and go into the advanced controls to make some adjustments. I'm going to switch the LLM option from GPT to Claude Sonnet. Then I'm going to go ahead and increase the max tokens. Finally, I'm going to change the system prompt to provide more guidance for the LLM, or Claude in this case. I want to leverage JSON formatting so that later we can easily parse it out and autofill an HTML code block. We'll get into that in the next video. We will share the JSON for you to use directly as well. Now I'm going to set up my prompt. Glif lets you inject outputs from different blocks into your prompt, allowing for a very nuanced system. In my prompt, I indicate that I want Claude to write a background and general details for this character using the user inputs and the randomized list inputs. I want it to base its response on official material from D&D and not make anything up, and also prioritize user input. I also re-emphasize that I would like this parsed out as a JSON. You can see the full prompt by remixing the link we've shared for this Glif, or we're also going to share a document just with these sections so they're easy for you to copy and paste and edit. Now we're going to do a second text generation. This is a little like the first one, but in my experience, you get challenging results from asking an LLM to do very different styles of tasks in one prompt. In this prompt field, we're trying to get the LLM Claude to generate a stat block, which should not be descriptive and narrative. So I don't want it to try to parse it out with descriptive and narrative tasks. In the previous box, we were asking for a background, which is descriptive and narrative. So I'm keeping those two separate. I will set this text generator up in much the same way. I'm going to switch to Claude Sonnet and increase the tokens. I will also edit the system prompt again, this time adjusting the JSON file to the following format for the specific information I want generated in this LLM block. This includes a random generated stat block, features, spells, and even attack modifiers. Now, just as before, I'm going to write a prompt to indicate the information that I want Claude to parse out its answers from. I've prepared this prompt ahead of time, indicating how to roll a stat block and where it should be pulling its information from in previous blocks so that its answers make sense with the rest of the generation. I have also included the character level again in this block to ensure that it actually follows the level. I found that when I included it in the descriptive background block, it had a tendency to come up with a different level than it should. For example, I would ask for level 7, but it would keep giving me level 5. The rest of the prompt just reaffirms what the LLM already knows, that it should be outputting in JSON and also not to be conversational. I don't want any intro sentences like, here's your JSON format, etc. Now we're just going to adjust the title and we're good to go. Next, let's run a little test. We'll try prompting an elven warrior at level 7. I've given it some context it will recognize from D&D, an elf. But warrior isn't an official class or subclass. Because we haven't formatted an output that captures more than one block, we'll only be getting the last block, the stat block, as it's the last output in our current chain. We're going to address this in the next video, but for now, this is just to test to make sure everything's working as it should. And what it should do is give us an appropriately flavored elven warrior. And there we have it. This is the JSON format for a dex-based elven warrior with high intelligence. I can pretty easily guess this warrior is probably an eldritch knight, which we can see in the class features. Claude has picked a feat, which the character would have received at level 4, and systematically filled out all of the important aspects that a DM or player would need to quickly use this character in roleplay or combat scenarios. Now you understand how to use multiple LLMs to create dynamic and interesting characters for your next D&D campaign. In the next part, we're going to talk a bit about how to make an automatically generated portrait using generative AI image creation, how to parse out the JSONs, and then inject all of that information into an HTML format so that you have a really nice final piece like you saw in the beginning of this video. Thank you so much for watching, and I'll see you at the next part. Welcome back. This is part 2 of building D&D character sheet roulette with Glif. In the last part, we discussed basically how to set up LLMs to output all the information that we need. This included text input, a list of randomizers, and 2 instances of Claude Sonnet. In this video, we're going to take those Claude outputs and use them to generate images and populate our HTML code block. First, we're going to set up one more LLM block. We are going to keep using Claude. Let's label this one portrait prompt. Go ahead and switch it over to Claude Sonnet. Then we're going to adjust the system prompt, and this will be different from the last one. We're going to ask Claude to specialize in image prompting for this particular block. Now we're going to make sure as well that this block creates a detailed prompt for our final image. It should look like a character portrait pulling from elements from the last 2 generation fields, backgrounds, and stats. So we're going to indicate that here. Once you have that all set, it should be pretty quick and easy because we're masters of Claude Sonnet now. We're going to pick the Comfy UI block. For those unfamiliar with Comfy UI, it's a program that uses nodes to run different types of open source image generation. I think probably some closed source as well. It's particularly focused on SD 1.5 and SDXL, and it uses a series of nodes. It looks a little like a 3D program if you're familiar with that. This allows for really complex and interesting workflows. In Glif, you can either edit directly in their test node viewport, or you can import your own Comfy UI workflow as a JSON block. There is a special formatting, so I'll include a link to the documentations about that. We're going to edit Glif directly in this one because this is a really simple workflow. I recommend running Comfy UI either locally or on a cloud system to parse out more complex workflows. This is the default Comfy UI workflow, which includes an IP adapter and an image input. However, we're just going to use text prompts in this, so we don't need those components. We're going to use a style LoRa to give us the style that we need, and everything else will be driven through the text itself. So go ahead and remove the IP adapter node and the image input node. I'm going to share the JSON file block for you directly, so you can just copy and paste that directly in, make your life a lot easier. You won't need clip vision or latent image input setup that we have here either. So you can just delete all of that stuff, and we'll get into what you do need. Okay, it's time to add new nodes and reconnect the nodes that are broken right now. So to find a node in Glif, double-click the interface, or screen, I guess. First, add a load HF LoRa. In this case, HF stands for Hugging Face, so that we can call a LoRa model directly from Hugging Face. This is great because a lot of people share really cool open source LoRas, or if you train your own, it's really easy to call it without, because you can't directly load it to Glif. I'm going to grab my own cartoon style LoRa that I trained. So I just need to provide the Hugging Face repo link and a file name to call it. So once those fields are populated, Glif will know to call the corresponding Hugging Face repo for the model. Now let's switch the base model to SDXL because that's what the LoRa was actually trained on. Using alternative base models can be great when you're trying to get particular styles. But if you haven't trained the LoRa on that same model, it can actually generate subpar results, or it won't really match the style in the same way it would have if you trained it with SDXL. After that, after we've switched the base model, it's time to connect to the nodes correctly. The LoRa should go directly after the model. So reroute the path accordingly, plugging the base model into the LoRa, and then the clip into the LoRa, and dispersing it as though the LoRa is the base model, as you saw before. We are still also missing a latent image input. Load the classic, if you're familiar with Comfy, empty latent image node. As you can see, it auto defaults to 512 by 512. We want to adjust the aspect ratio to 1024 by 1024 because that's the correct size for SDXL. And actually, it can produce poor results if it's too small, especially with LoRa. We only need one image to generate, so that part can be left the same. Now it's time to adjust the prompts. Typically, the Hugging Face repo for a LoRa, if it's not your own LoRa, will give you context for what you need to prompt. So I'm going to add a few simple negative prompts that you can see directly in the repo here. We already asked Claude to generate the prompt. So here, just write in the correct title of the prompt block. In this case, it's just portrait-prompt in brackets. The brackets are what you need to be able to indicate that you're calling it from the glyph that you've set up already. I'll also add portrait of and illustration style to really like solidify the style and the composition. We're almost done with Comfy UI. There are a few K-sampler fields I'm going to adjust based entirely on personal preference. I'm going to increase the step count to 45 and the CFG to 7. I find that style transfers more fully at a higher CFG. I'm also going to change the sampler and scheduler to one with higher fidelity results. You can see that right here. And lastly, I'm going to add noise just like a tiny bit because I just find the overall results are slightly improved. Now the Comfy UI node is totally set to generate a corresponding character portrait. It's time to set up the two JSON extractors and the HTML block. Load a JSON extractor block. We'll use a separate block for each of the earlier LLM outputs, so it's going to be 2 in total. Starting with a character background, make sure that each of the fields requested in the original LLM prompt are also parsed out and called through this JSON extractor block. One by one, you will need to fill in the corresponding information. Honestly, providing a fallback text is not required, but it can be a nice touch, especially if you want people to use it. Like if something doesn't work correctly, it's great that they understand why. Or not even why, just that it didn't work, that it's just not a blank field. Once the first block is filled, do the same for the second block, which corresponds with the stats JSON from the last video, so that stats LLM call. Doing this will allow you to call all the corresponding information and parse it out. That makes this really easy to create a dynamic design with our HTML block. Otherwise, it would just sort of be a long block of text. It would be very hard to format. And this way, we can really just format it by individual pieces without having to prompt every single individual piece as a separate block in our glyph. The last step in the workflow is to create the HTML block. In this case, I actually worked with Claude Sonnet off screen and provided all of the information I needed in the block to create the HTML. We'll provide a file for you to use if you want to recreate it. It's a lot easier than going through and trying to explain it. Perhaps that'll be another video. For each content block, you can actually plug in a different specific JSON output to populate the correct information, such as backstory paragraph, inventory, stats, etc. You can also call your image generation indirectly by indicating that box in brackets as a source of the image. Now let's test out the character sheet. I'm going to quickly describe the character, a female halfling rogue, and set the level. Once you hit Run Glyph, you'll see the different blocks called and completed in order. Generative blocks like text and images can take a bit longer. The JSON block will populate as soon as the text is correctly formatted. And there you have it. Each detail that we outlined is generated into a corresponding area, creating a usable character sheet on the fly. It also has placed our character portrait up at the top. Once we hit publish, your glyph can now be remixed as well, used by other creators to riff on and ideate for their own designs. In fact, you can do that with our glyph. If you're unsure about anything here, you can just click remix and it'll allow you to create your own straight from the glyph we already made. Well, anyway, thanks for watching. Hopefully this gives you some inspiration for your own glyphs. And until next time, I hope you enjoy trying out the platform. Hey there. I'm Minta. I'm going to walk you through how to make an expanding brain meme. And this is a really great beginner meme if you've never used Glif before. It allows users to input a word or a phrase, and then it outputs basically a meme based on this very well-known format. So this should give you a good context for how to do the same with any number of memes. It's sort of a very easy to reproduce workflow. First, go ahead and click the build button. This will start a new Glif project for you. The first Glif spell block that you're going to want to use is the text input block. This is what users will see when they try out your Glif. Give it a quick text title like I'm doing here so the user knows what to submit. It also can be helpful to give them the context of what meme it is because they might not realize yet. Next, we'll use the text generator block, which is going to actually load an LLM for us. This will generate all the text for the Glif that the user input right into the prompt for the LLM. Go ahead and open up the advanced controls and we'll make some quick adjustments. I highly recommend using Claude Sonnet 3.5 for the LLM that you're using in this meme generator. It's really clever, it's irreverent, and it seems to understand a lot of pop culture and internet references. It's not very hard to get it to be very meme lordy. I find that this one makes the best outputs, and I also find it much easier to direct than other LLMs when it comes to avoiding non-narrative, etc. Other adjustments that I suggest are to increase the max token to 2,000 and to edit the system prompt from the generic system prompt. I like to expand the system prompt window so it's easier to read while I do this. Check out how I've formatted this text block. I'm also going to include it as an accompanying text document because it's quite a bit to parse through. It's important to describe the meme as well as you can in the system prompt and also its component parts, and use any common names associated with the meme because it likely has that in its memory. Notice how I'm describing in full detail, going panel by panel and giving a lot of context for the meme format. I'm also identifying that I only want a few words used as the output to avoid it spewing out tons of text. It's also really important to provide an example of an output in the format you want the LLM to create. In this case, we're going to want every output as a JSON format so that we can easily parse it out and use it in our canvas later as different pieces. Alternatively, we would have to generate each panel as a separate text, and that would be really inefficient. That was just the system prompt. This is basically how you guide the overall brain of the LLM. We still need to do the general instance prompt. In this prompt box, we can use the name of the earlier spell block in the brackets to inject information into the prompt. In this case, the user input will be injected. So whatever that user has put in as the context that they want for this Glif. I'm also providing more context for the prompt itself and reaffirming the overall tone that I want the AI to use. Adding start with the JSON, just go also tends to help avoid the AI getting too narrative and breaking the JSON formatting. Next, we need to be able to parse out the JSON into a usable format using the JSON extractor block. This is important for using it in the final canvas, which will be our last block. Here, you should list the fields from the JSON in the text generation block. Make sure you also identify the text input coming from that block. You can sort of see it here, like panel 1, panel 2, panel 3. This part is pretty easy. We're just telling the extractor what in the JSON text it should be parsing out and also what it should rename that output as so we know how to call it in the canvas. The most important part is that you are using the same name to source from the JSON that the LLM created in the text generator and also using that name in the corresponding section. So panel 1 with no space should again be panel 1 with no space. Finally, it's time to put it all together. For this workflow, go ahead and use the simple canvas block. Resize it to make the size of your meme background file, and in this case, change the color to white using the hex code. Click the image input button. It's shaped like a little picture here, and click source. This will give you the option to upload a background image. You can see here I'm uploading a blank version of the expanding brain meme. Now you just need to resize the image and set it where you want. Click the text box button and add your first text. I'm going to go ahead and change the text size, font, and alignment. Here's where the JSON extraction comes in handy. Click source and pick the JSON field that corresponds with the panel from the original prompt. Adjust the text and repeat this step for each text block. I like the versions of this meme where each panel has a different font, so I'm going to be doing that as well. Now the Glif is ready to test and publish. I always recommend doing a quick test in case there's any little bugs or any errors popping up that you want to fix. You will also be able to edit it once it's live, so don't stress too much. Once you're happy, hit the publish button and share it with the world. I hope you have enjoyed our video, and thank you for joining me. Until next time. Hello, I'm Minta. Thank you for joining me today as we explore Glif. You may have seen our other video where we built a simple meme Glif using the expanding brain meme. We're going to dive in a little deeper and create a more complex meme with this video. Here you can see the more advanced Wojak meme generator created by Fabian. This meme generator is designed so that a user can input a word or a phrase, and it will create a classic Wojak format meme. In this video, we're actually going to show you how to effectively remix a Glif like this one that you might like to make a more advanced meme structure from using, in this case, image generation, LLMs, and an HTML block. You can go ahead and start by clicking the Remix button. This will create a remix draft of the Glif for you to work from. Rather than starting from scratch, we're going to just go ahead and edit already existing blocks. First, change the user input text to fit your meme. In this case, I'm making an irreverent occult style meme, so I'll adjust the text accordingly. Next, let's adjust the LLM instructions. We will delete the text that is really Wojak specific. So instead, I'm going to tell it to be dry and irreverent, a bit chaotic, and say one occult thing. That might sound a bit silly. I find that if I overemphasize the occult aspect, it actually starts to create almost like a boring and predictable meme generator. Then we'll open up the advanced controls so that we can adjust the system prompt. The model is already set to Claude Sonnet, which is perfect, so we just need to adjust the text. Again, remove all the Wojak related text. I'll provide a recommended text as a file for you to review separately on your own, but as you can see, I've referenced a few different meme formats that I want it to consider. I've also outlined the overall format of the second text block and the JSON. Most importantly, I've shared an example of the meme, so it has something to work off of, and I've formatted it in the JSON style. Lastly, I've given it some content moderation rules to follow, which is pretty useful. Now we can go into the JSON extractor block. Again, we're just going to go ahead and adjust these block components. We want to make sure that this matches the memes as we've designed it in the last block, so we'll need to change some of the output categories. Luckily, we did not change much, so I can just remove one of the lines and change another to match the intro section as I identified in the system prompt for Claude. In the Wojak meme, the creator had used a separate Glif to generate the Wojak face, one they had previously designed. However, we're going to generate a totally different image, sort of a chapbook style, in a different way. First, I'm going to add a comfy UI block here so we can quickly generate the image that we need. I'll provide the JSON for you to make it easier to just copy and paste into the comfy UI block, and then I'll go through the nodes here just so you know what we're looking at. This comfy UI workflow includes an empty latent image block, 2 custom trained LoRa's, text prompts, and lastly, a background removal block. The goal is to use all this to generate a chapbook-style block print image with no background. We're also going to go ahead and remove this canvas block. The canvas is great for casual meme formats, but we want to do a little extra formatting finesse here. I've worked with Claude Sonnet separately to come up with a more complex HTML format with some fonts not yet found in the canvas. I'll provide the text code for that, but also just show you what's going into it. Just to review, I've outlined the various formatting blocks, identifying different fonts and weights for the text input. I've also used the extracted JSON components to call these individual text blocks, intro, header, the different formatted sections after that, so that we can parse them into the final formatting. If you use this HTML, make sure to edit any fields here that you've changed on the JSON extractor if you make a different type of meme. Lastly, we make sure to call the image from the comfy UI block. That way we have the image formatted as a side panel with the text as another side panel. Now our occult meme lore generator is ready. It's always worth giving it a test run before publishing so you can make any tweaks. This one has a few steps, so it's going to take a moment to generate, but not too long. As you can see, all the blocks are being called and completed in the correct order. That's really the most important piece that you want to look for. And here it is. The output definitely matches the goal. Thanks for joining us for this walkthrough, and be sure to watch our other videos for more inspiration for your next glyph. Hello! Welcome to our tutorial on how to create a portrait restyler on Glif using Instant ID. Glif is an AI sandbox platform that lets you easily build AI mini apps using LLMs and media generators. Your own Gen AI Lego kit, so to speak. The Glif that we're going to go over today is designed to let users upload a portrait and pick a style from a menu, generating a new image of their face, completely stylized, without losing important facial features. To start, navigate to the Build section of the Glif site. This will begin a new Glif project for you. Glif blocks, also known as spells, are the components used to build our mini apps. For this project, we will start with an image input block. Users of your Glif will be able to see this and upload their portraits to it. Let's rename it to portrait to make things easier ahead of time. Normally, we'd include a text input, but in this case, we actually want to provide the text for the user. So instead, we'll use the multi-pick block. This will turn into our drop-down menu. Let's rename it Style Dropdown. We're going to make the drop-down menu correspond with our repository of LoRa models on Hugging Face. Hugging Face is an open source AI platform where people host models, demos, and other pieces that you can use to build AI projects and apps. The LoRa models we're going to use will dictate the style for this workflow and guide the base model, SDXL, the one that we're going to use. The best way to call and swap out multiple LoRas, in my experience, for this type of workflow is directly from Hugging Face, which I'll show you how to do in the next video. But in this video, we're just setting everything up. We're also going to provide a supplemental video which will explain how to build a repo with your own models or models you find in the space. You can also, of course, access ours easily on the Glif Hugging Face page. For the multi-pick, we're going to choose names that we most want to have in relation to the model styles. Once you have a full list, don't forget to label the drop-down menu. The next block to add is a text generator or LLM block. This will allow you to have an LLM guide, a chatbot, to guide the LoRa model calling function. We're going to keep the prompt super simple. Just have the multi-pick style drop-down text as the main prompt. The magic will take place with the system prompt. Open the advanced settings. First, let's switch the LLM to Claude 3.5 Sonnet, a personal favorite of mine. Next, we're going to rework the system prompt. Don't worry, we'll provide the text for you to alter yourself. In the system prompt, we directly explain the LLM's task to parse out from the information given the correct corresponding safe tensor file, that's the LoRa file, and how it should be formatted. You can get the safe tensor names directly from the Hugging Face repo. Make sure to show exactly which name corresponds with which safe tensor file in the format we've shown here. Go ahead and rename this block safe tensor. For the final block, we will add a Comfy UI spell. Comfy UI is a node-based image generation interface that allows us to create complex image generation pipelines using open source scripts. We'll get into the Comfy UI build in the next part of this tutorial. Don't forget to check out our supplemental video that explains how to set up the Hugging Face repo. And I'll see you in the next video. Thanks. Welcome back. In the last video, we started building a portrait restyle AI app using the Glif platform. As a reminder, Glif is an AI sandbox that lets you easily build AI mini apps using LLMs and media generators. When we last left off, we had designed most of our Glif. We used an image input for a user portrait, a multi-pick drop-down menu for different styles, and an LLM block to help us parse out the correct corresponding safe tensor file. We also added a Comfy UI block to create a complex image generation pipeline, which we're going to get into in this video. For the Comfy UI workflow, we're referencing Cubic's workflow for Instant ID with some of our own style modifications. Instant ID is a really cool program that lets you take a portrait of a person and it actually interprets their face keeping a lot of the very important details that would otherwise be lost. Cubic's GitHub page has great resources, including a video overview of how to leverage Instant ID in a multitude of simple and advanced pipelines. We've just taken one of those pipelines and tweaked it a little for our own uses. We've provided a JSON file that you can copy and paste directly to quickly populate the correct nodes. Let's go in and review the nodes that we put into Comfy UI. On the left-hand side, you can see where we indicate the model, Albedo Base XL, a fine-tune of SDXL, as well as the image loading node that indicates in brackets to pull from the user input. Additionally, you can see 2 Instant ID model nodes for loading the corresponding Instant ID components. Between the checkpoint model and the prompt box, we've also inserted a LoRa call from Hugging Face. You should remember this from before. Because we've loaded all the models into the same repo, that can be entered as a static value, as you see here. However, we want a user to be able to dynamically choose the style they want. So the block we set up that parses out the correct safe tensor file will be generated into this spot, as you can see. We're also going to call out the style by referencing the user's choice from the multi-pick and injecting that into the prompt. The JSON input seems to remove the brackets from the prompt sometimes, so make sure that you call for the multi-pick block and that you format it correctly and it corresponds with the name you choose. You can see what you should be formatting it as in the lower left-hand corner of the Comfy UI modal. Next, we have the Instant ID block. Depending on your goals, the strength of the Instant ID can be changed. We're going to show you a couple examples of that, but first, take a look at the case sampler. These are the settings we recommend to correspond with the Instant ID setup. Now, it's time to test the Glif. We've set the Instant ID to a 0.6 strength for this first run. We will upload a portrait and just go ahead and pick, let's say, embroidery style. As you can see, even at 0.6, the face transfers over really nicely. Let's go back and try it on another setting, 0.9, quite a bit higher. Here you can see the style is sacrificed a little for the structure of the face, but the face representation is much more accurate. Likewise, with 1.0, some of the realism is injected back in, but the face is much stronger. It's wise to test out your settings with the styles you've chosen before publishing your Glif, because different styles will respond better or worse to different settings. That is the overview of our portrait restyle workflow. In our final video, we'll go over how to set up a Hugging Face repo that corresponds to this Glif. This video is supplementary, so if you prefer not to go into it, it's totally optional. Anyway, until next time, happy glyphing. Hello, and welcome to our Glif video tutorial. Glif is an AI sandbox that lets you easily build AI mini apps using LLMs and media generators. This video is a supplementary guide to creating your own Hugging Face model repository to accompany the Instant ID portrait restyle workflow that we shared in 2 separate video parts. In the previous video, we explained how by using a list of corresponding names and an LLM, you can instruct the AI model to parse out the correct safe tensor file based on the multi-pick tool and a list you've provided. For more on that, make sure to watch part 1 of our portrait restyle series. We provided a repo for you to use, but if you'd like to create your own, there's an easy process to follow, which we're going to go over now. First of all, you will need to have a Hugging Face account, which is totally free. Hugging Face is a website where a multitude of AI models, research, and demos are hosted. It's super fast and easy to use as a space for calling models into Comfy UI workflows. To start, go to your little profile picture icon in the top right of the screen and click New Model. Next, assign a model name formatted for a web address format and choose a license. This should correspond with the LoRa you use typically, but often it's going to be Creative OpenRail M or one of the other OpenRail licenses. Of course, be sure to check if you're using a LoRa for commercial purposes that you don't need additional permissions from the LoRa creator. You will need your model repo to be public for this to work. If not, you won't be able to call it with your Glif. Now, just click Create Model. Your model card will be empty, but it is really easy to upload files to this repo. Simply navigate to the files and versions. Then click Add File, and then Upload Files. This is where you can drop in one or multiple safe tensor LoRa model files. you will need to make sure the files you're using are a typical LoRa safe tensor format, and that they don't require an embedding to operate. This workflow just doesn't allow for that. Click Commit Changes to Main, and your files will begin to upload. Now, all your files are accessible from the same repository. These are also the safe tensor file names you will need for the LLM block part of Part 1 in the Portrait Restyle Guide videos. Okay, that's it. Time to get back to the full tutorial. See you back in Part 2.
Hello and welcome. In this tutorial, we will be exploring how to use Instant ID and ControlNet to create a unique character illustration using a portrait, guiding pose, and a short prompt on Glif. Glif is an AI sandbox that lets you easily build AI mini apps using LLMs and media generators. Let's jump right in. First, start by clicking the Build button on the top of the screen. This will launch your Glif project. The first Glif block that you will add will be an image input block. This is something that other users will be able to see and upload their images to on your published Glif once it's done. Go ahead and rename this to Person 1 and make sure the description indicates the user should upload a portrait. Now, add a second image input. This will be the character pose. Follow the same steps. Change the name and description so a user will understand what to input. And make sure to pick a picture that indicates the final pose that you want. The final user input block we'll want to include is a text input. This is going to be where a user's prompt can be put in. This is an optional box because the prompt has minimal impact on the overall generation. But it can be a nice touch for a user and add a few extra stylized details. If you want it to be optional, just add a little space in the example area. We've finished including the user prompts. It's time to add some generative blocks. First, we'll add a text generator. This is hooked up to an LLM or language learning model. We'll provide text documentation showing the exact changes that we make to guide this LLM. But as an overview, we're using the user prompt as the input for the text generation prompt. Let's set the LLM to Claude 3.5 Sonnet. We're next going to adjust the system prompt. We'll keep it simple and creative and give the model an example of the input and the output it can expect so it knows exactly how to behave. Again, you can find all of this in the supporting documentation. Once it's done, it's time to create a comfy UI block. This is where we set up our image generation pipeline. We'll provide a JSON block, just as we did with the other documentation, that you can copy and replace the default JSON text with, like so. Let's explore what is driving this comfy UI block, however. Here you can see all the nodes we're working with, including base model and various image inputs. The image inputs have been adjusted to reflect the titles of our user input blocks. We're using both Instant ID as well as Misto-line ControlNet model that follows a distinct outline of our second image as a guide. The ControlNet model plugs into the Apply ControlNet node. For this workflow, I have set it at 0.75 strength. I also have plugged in the image that I would like to use for this pose. That same image will get plugged into the image KPS, which guides the Instant ID by providing key points. What this means is that it's doing a quick map of the face, both in size and direction, and using that to guide the overarching Instant ID face input. Make sure the image input you have is set to the pose input block. We're using the ControlNet because the KPS isn't going to pick up how the body is structured, just the facial details. As we discussed in our last Instant ID video, which you can find in the Glif YouTube or documentations page, the other images will be mapped and reproduced using a more general Instant ID/Insight face input. So, combined, we should see the face details of the portrait image preserved and overlaid on the pose details of that second image. Let's give it a try. I'm going to upload one image for the portrait. Straight on images tend to work best where the person is looking directly at the camera. Then I will add a separate image for the pose. I'm going to use a fairly simple one here, but you can get more creative with it. Now I'll put a short character description, which the LLM will enhance. As you can see, the image is stylized using the LoRa I input and chose in Comfy, and the face is kept the same, overlaying it on the pose we provided. And that's it. Thanks for joining me for this workflow overview. Until next time, happy glyphing.
Hey everybody, welcome back. we are going to get into some really cool stuff in today's tutorial. For those who are new to the series, we're diving into how to build mini apps on Glif. And Glif is a no-code AI sandbox, allows you to build and publish workflows that are shareable and can do some really cool and amazing stuff. So the biggest thing we're focusing on in this video and the video that comes after it is using Glif blocks, that is, using existing mini apps to power smaller parts of your Glif. So let's hop right into it. The way we've chosen to really dive into this is actually to show you how to do this animate yourself feature. As you can see here, it creates these really cool, cute mini animations. And in the next video, we'll go into like how you can customize those a bit further, how you can do your own video inputs. But for now, we're going to really focus on the initial image that you're going to need to drive the video. So first and foremost, let's just take a look under the hood here. As you can see, there's a lot of different mini components, but what we're focusing on today is this middle block. This is called all of these are blocks, but this is actually a block that calls other glyphs. This is the glyph that it's calling, and this is what we're going to show you how to reproduce today. As you can see, you can put in a portrait here, and it's going to output a stylized version of that portrait in a sort of like hand-drawn kind of pencil and maybe a little watercolor way. So first and foremost, you're going to want to hop over to Build, and that is going to open a new project for you. Next, we're going to do this first block, which is image input. The image input block actually allows a user who uses your final mini app to upload their own image, whether it's an image of themselves or someone else, to the Glif. Next, we're going to do a text input. We're going to make this an optional block, and I'll show you how at the end. But basically, this allows your user to add any extra prompts they might want to. Maybe they want to stylize the character a little bit more. Maybe they'd like to change like the color of the eyes or the color of the hair. It just allows a little more flexibility for your end user. And we really want to empower you to be the creator here and think about your audience. Next, we're going to go ahead and grab the Glif block. And this is going to feature in both of our video tutorials, both this one and the next one. So the Glif block, like I was saying before, allows you to call an existing full Glif app. We're going to call this one Vision because that's what it's going to do. It's going to look at the picture that the user has input. As you can see here, Glif actually provides you with a number of pre-generated glyphs for this Glif block. Go ahead and click GPT Vision. That's the one that we want here. Next, we will provide you with this text prompt that we're going to be using, but basically it's telling the model how to think about the image that we're going to present to it. So it gives it sort of like a job to do, right? It's going to also indicate to the model the way we want that prompt to read, because this is going to be our end prompt that goes into the image model. And if you're familiar at all with image models, the way that the text is written for the image model is super important. It can really impact the final result. So we're really describing to the GPT Vision block how it should not only interpret, but also respond to an image. Next, we're going to indicate that image input, that original block that we first set up where a user can upload their image, that is going to be where it pulls the image from that it's looking at. And finally, max tokens. We don't need a lot of them, so we're just going to do 50 tokens as the max. Next, and our second to last block is the text combiner. Now, this is really important because we did give the user the option to basically customize this. So we need to create a way for their prompt and the prompt that the AI model is creating to be combined. So I'm going to also add some stylistic indicators here. For example, I'm going to say sketch of, and then we're going to put vision in. That's that little green or the sort of blue-green block. And then features, which is the user input, which is a light green block. And you can actually see them at the bottom there. And then a few more stylistic prompts as well, just to sort of guide the overall style. And then lastly, we're going to go ahead and grab this Comfy UI block. Now, this is super useful and important. Comfy UI is a node-based image generation program. So basically, it allows you to draw from lots of different open source programs, as well as pulling models from various parts of the community to create these really advanced image generation workflows. So we'll provide the JSON here for you to generate with, because that part is a little more nuanced, and that's going to populate all the nodes that you need. But we are going to jump in just a second, and I'll describe to you exactly sort of what each one is. So first and foremost, we're using IP adapter, which is sort of image prompt adapter. And basically what this does is it looks at the image originally and allows you to draw certain, or allows the model to draw certain conclusions from the image that it's given. Now, we're using plus face here because it's for portraits. You could also use Insight ID, which is available as well on Glif, and we did a whole other video on that. So definitely check out the video. We'll link it below. But for this one, we're going to use just the traditional IP adapter, which is plus face in this case. We are setting it at kind of a low strength because IP adapter does try to transfer some of the style details, and we don't want too much of that bleeding through. We're also going to start and end it at a little bit of a different point. This just sort of helps dial it in a bit. You don't really need to mess with this too much unless you are really familiar with IP adapters. The only thing you might change is the weight of the IP adapter, in which case that's something you might want to play with your results and see what weight works best for the style that you're using. We're going to use the standard setting. There is also the prompt is more important. That's going to just take a little bit of information from the IP adapter, as well as the IP adapter, the style is more important, which is kind of going to ignore the prompt. We want it to be right in the middle. Next, we're going to apply control net. This is going to also add some structure. So it's basically going to look at the image input and pull a good amount of structured details out of it. Those we're setting to a 0.5 strength. So it's still giving a lot of flexibility for the style, but it does tend to guide it quite a bit more. So as you can see here, we're showing a little bit about the type of mapping that you can use. You can use any sort of like input image, and it's going to actually map all of the line work as well as the weights of those lines. And that's what the model is looking at when it's using control net misto line, which is what we're using here. And then finally, we have the LoRa input. So this says load HF LoRa. If you're not familiar, the HF stands for hugging face. And this is a big repository of different models. In this case, we're calling a cartoon model, actually from my repository, but you can call any public SDXL model for this workflow, and it will work as long as it's a LoRa model. Finally, I've added some negative prompts here. These just are going to, again, tweak it a little bit more. If you switch out your model, so if you use a different style model, you might need to adjust that negative prompt to accommodate it. For example, if you're using like a photography model, the negative prompt that I've used is not quite appropriate. Last, we have the K-sampler. So this is like all of the hyperparameters that the latent diffusion model needs. And as you can see, they can get a little bit advanced. If you're not familiar with it, I recommend just leaving them. But if you are familiar with Comfy UI or with image generation, feel free to tweak them to your preferred hyperparameter. So those are all the components we need for this workflow. As I mentioned earlier, we do have a way of making the text optional. It's a really just mini hack. You just have to add a space in the example on the left. So if you go and click there, click the space bar once, now it's not going to be a big deal if someone doesn't input any text. So let's test it out. We're not going to add any text this time. We're just going to upload that same picture again and see what we get from it. And yep, we were able to get the output that we wanted, a nice little cartoon illustration. So in the next video, we will jump into how to animate that in a really simple way. But until next time, thank you for joining us for this video tutorial. Welcome back to our Glif tutorial series. In the last tutorial, we talked about how to take a portrait and restyle it so you can get a very stylized, in this case, a cartoony, sort of hand-drawn, stylized output. The reason for that is because we're going to use that output in this cartoon animation. And in this case, it's really more like a mouth and eye animation, but very consistent animation output. So as you can see here, we have like a couple examples of what it might look like to animate that. And we're using one video, but we'll show you how to use a few different video inputs so that you can set it up to whatever video input you most like. As you may recall, this is the Glif that we were originally calling. So we made this Glif in the last video. We walked through all the steps and you were introduced to the block that calls other glyphs. And this is super important. In the last one, we actually used a glyph provided by the platform. So we were able to call a pre-made glyph. But in this video, we'll actually talk about how to call a glyph that's not made by the platform, a glyph that's either made by you or made by another community member, because all glyphs are currently public, at least at this stage. We're also going to grab some code from this glyph. Now, we're going to be using Live Portrait to sort of power our animation. Live Portrait basically looks at the eyes and the mouth, ideally of a straight-on video where it's sort of framed the way my face is framed. And it uses those as guides for the final animation. So it's really just animating the mouth and eyes. And it's a pretty complex workflow. So we're actually going to grab this JSON. We're going to go into the source and find this piece because AP, one of the Glif team members, already outlined it for us. And this is the great thing about Glif. You can sort of share and learn from other community members really easily. It makes it a super powerful and super communal work experience. So we're going to go in to build. That's how we start a new project. If you didn't watch the last video, if this is your first time, go ahead and go into Glif. And our first thing that we're going to do is pull up the Glif block because, well, you'll see why. So the Glif block here, as you can see, we have that drop down of all of these pre-made glyphs that we can call. But in this case, we actually want to use our own glyph. And to do that, we need to find the Glif ID. Now, the Glif ID is unique to every glyph, and this allows you to use a glyph that you've created or a glyph that someone else has created as a standalone block in your final workflow. So in this case, we're using Cartoonify Yourself, and to get that code, we just have to go to the web address and pull that last line of numbers and letters at the end of the web address. So we're going to drop that in. So now we can immediately see it's calling the right one. It calls the title correctly, Cartoonify Yourself. It's also showing us the inputs that we're going to need. So this is super important information because this really identifies for us what we need as input blocks. So we need an image input and a features input, and that we know that's a text input. You can always go to the source of the original one if you're unsure what that input is. So we'll upload that image input first. This is the user portrait, and this is straightforward. I know that a 1-to-1 ratio is what we need to create a really good final live portrait video. So we're going to indicate that as well, and the user will see that. Next, we are going to go ahead and do a text input because it really does require it in the glyph that we created. Now, we can do the text input as a user input, which we're going to do now, and that allows them to stylize it more. It gives your user a little more control. If you don't want to do that, you can actually just write the text input yourself into that line. You don't have to call a separate input block. You can sort of determine that and make it a fixed input, in which case you just do it in the box underneath features. But because we've put those two input blocks, we're going to start with the image input first. We're going to indicate that, and then we're going to indicate the prompt feature as our features input. And then let's just go ahead and rename this to Portrait Generator. And we'll go to the next piece that we need to build. And it's a pretty simple workflow after this. Now we're just doing Comfy UI. So if you might remember from the last video, Comfy UI is a multi-nodal tool that allows you to plug and play different open source tools and image generation models, such as SDXL, Flux, etc. In this case, we're using SDXL. So we're just going to go ahead and copy and paste the JSON that we saw before in that live portrait workflow. And here it is. As you can see, it's a little bit complex. We're going to keep it really simple for this video. I will provide some links that allow you, if you want to nerd out on like how live portrait works, etc. There's a lot of cool links on it, but we're going to keep it very simple. We just want to show you some basic features. And the main feature I want to show you is how to swap out the video if you want to. Now, the main thing here is we're going to call it from a Google Drive. The most important aspect is that it needs to be shareable. So you need to basically have a Google Drive folder or a video on Google Drive set up with full sharing permissions. I've uploaded basically as many of the open source videos that you can see as examples for tools like Live Portrait up here. If you make your own video, it's a little tricky, but I recommend doing straight on portrait, face framed, as close to a really consistent 1-to-1 ratio seems to work the best in the videos I've seen. But here, we're just going to show you how to swap it out with one of these other open source videos. Similar to the one before, the Glif ID, we're going to need to share with the unique ID for this G Drive asset. But first, make sure, double check that you've made it completely shareable to anyone with the link. And then go ahead and copy that link just so you know what the link is, or grab it from the top web address and just grab that unique series of numbers and letters between the D / and the / view. So go ahead and copy that. And we don't want the sharing link because that won't work for the way this is called. We actually need a download link. We've already created that download link for you from G Drive. You just need to replace the series of numbers and letters after the ID and the equal sign, and that will call the correct Google Asset ID from G Drive. So we're using Live Portrait, as I mentioned before. Live Portrait, again, is a really cool program for mapping the eyes and mouth of a video, specifically a human video. I believe the newest Live Portrait also has animal video, but I haven't had a chance to test it yet. And then we are just going to go ahead. I don't want you to mess with any of the other nodes unless you're really familiar with Live Portrait, because it can get a bit complex. And the only other note I would say is that the video needs to be 30 seconds or less, because that's what Glif can support at this time. So let's go ahead and test it out. We're going to upload an image, add just a couple spaces to the prompt feature, and let's see what we generate. And here it is. Yeah, so it's following the mouth. The eyes didn't really move much in the video, but really following those mouth details. I've noticed some videos are better than others, and it seems to depend a lot on sort of like the clarity of that framed face and also the range and speed of expression. So you can really go down a rabbit hole of testing videos or testing your own videos, but I hope this gets you on the right path and opens up a lot of new cool possibilities for you. Thank you so much, and I'll see you in the next video.
Hello, welcome to another tutorial about Glif. If this is your first tutorial, Glif is an AI-powered mini app builder. Basically, it's no code, sort of Lego for AI tools and toolkits that allow users to plug and play LLMs, language learning models, image generation models, and more to make these really complex and interesting outputs. And today, we are going to be doing a deep dive into the virtual clothes try-on by Fabian. So Fabian, of course, one of the founders, and this is the virtual clothes try-on, which allows you to reskin the fabric of garments. And as you can see here, it has both two image inputs as well as a variable control. So this allows users to either make super specific control or a little more flexible control, depending on what they're looking for and what they're trying to do. So as you can see, if you make it fit very loosely, it's just sort of following the edge work of the garments, whereas if you fit really, really tightly, you're going to see here in a moment, it actually follows the actual pattern, and it just reskins and recolors that pattern itself. So you can get quite detailed with it, and you can even use abstract concepts like we're doing here. So for example, we can turn up the control of all of the line work here so that it really sticks to the overall shape and structure of the garments, the outfit, as you would say, and then we're going to reskin it with the colors and the concepts of this this special sort of like candy skull head, the Dia de los Muertos style skull. So as you can see, it creates this really cool, interesting, and unique pattern. So we're going to go ahead and dive in and view source. This is how you can look at other people's glyphs before you remix them to get an idea of how they work. So this is a few different user inputs. First and foremost, it has an image input. This is going to be that first image, the garment outfit image. The second image input is going to be the style image. And like we just said, it can be another outfit, or it can actually be something more abstract, like a candy skull, maybe feathers, etc. And then lastly, we have this control net strength, CN strength. This is the amount of structure that we're maintaining. So do we want to follow the patterns of the person's garment, the exact line work, or do we want to just follow generally the shape and structure? So this is going to give us that level of control. And of course, you want to label it because your users need to know as well. Glif is for sharing, not just for ourselves. Next Glif block here is actually something called GPT Vision. If you've seen any of the other videos, you've probably encountered this before, but basically this uses GPT to look at an image and describe it. So we have a bit of a complex descriptive prompt here, which we'll include in the documentations to go with this video. And we are going to put in the style image. So we're really trying to give both a prompt and an image, and we're having the LLM actually interpret what we've put in into a style. Next, we're using a second LLM, Claude 3.5 Sonnet, to further interpret that style prompt. So we're giving it that describing style that we just generated, and we're asking it to come up with a fashion trend to get sort of interesting, unique. We do it in all caps because that often gets interpreted in a way that's really interesting and cool for styles. And as you can see here, we even got like very specific with the system prompt. So the system prompt is sort of like how you want the AI to think and respond to different aspects of what you're asking it to do. Next, we have IPA strength. We'll talk about this a little more in a minute, but basically this just is a quality of life improvement. This will allow us, if you were building this, to adjust your IP adapter, which is image prompt on the go. Likewise with mask blur, it just means that later when we're using Comfy UI, you don't have to keep going in and out of Comfy UI. It's like sort of setting up your own intermediary UI outside of Comfy UI. The same with the one before, and now we're actually in the prompt, which is going to allow us to add that describing style. And you could as well add the trend here. And then we're actually targeting. So here, this actually goes into a segmentation tool. In this case, we're targeting outfit. You could always do dress, clothing, etc. In this case, we're choosing outfit. And then finally, Comfy UI. So as you can see, it's very complicated. We're going to go through each section and just talk about what it's doing and why it's there. So we have a bunch of segment anything models up here. That segment anything is actually going to look at the garment and crop it out, basically. Allow us not crop fully, but like mask it out. So we're just generating in that area. And we have a few different components to that. We have the model loader. Of course, we have that image, which is going to be plugging in both to segment anything and to control net, which is giving it that structure, a greater or lesser structure. We also have the grounding dyno model, which is a part of segment anything. And then below that, just for reference, is where our checkpoint is. You can see there's a few different options here. You could potentially use realistic vision. We're using Juggernaut X, which is by Run Diffusion. We also have those variables. So this is the IPA strength. This is going to go into our IP adapter in a little bit. And again, that's that quality of life improvement. We have the control net, which is swinging all the way up to the apply control net. Again, that's that user input that allows the user to control the structure of the garment and how much of the pattern and overall like fold and different detail work of the garment is held. Next, we have that second image input. This is the style going into the IP adapter. This is what's giving us that super stylistic element. And then finally, we have the mask blur. So the mask is that segmentation area. And this allows us to blur the edges of the mask and allows it to be either less or more blurred and less or more stretched out from the original mask area, giving it a little bit of a more natural shift. As you can see, we can grow that mask as well. And that's being controlled in a really straightforward way in that sort of modified UI that we had created in the Glif build itself. As you can see, we also have our K-sampler. I definitely recommend doing this if you have a little experience with Comfy UI, and this you should have experienced before. The K-sampler just guides your generations. We're finding that Euler A is the best one for this particular workflow, that you get some kind of odd results from other K-samplers, even if those K-samplers work well in other situations. Of course, this is going back to the grounding dyno segment anything model, and the target is that outfit that we identified. Again, that quality of life piece where we can swap it out later. And then all of this is coming together in the IP adapter, which is plugged into that image that we had originally been running through. And we are adding the strength. I think it was a 1 that we had on that last screen. And that's actually helping us to apply the style. It's pulling a lot of visual information from the style itself. All of this comes together, runs through that control net piece, and this is really the full generation pipeline. As you can see, there's a lot of pieces to this, but really a lot is possible with Glif, and this is just sort of a peek behind the curtain. Hopefully it gets you inspired and walks you through just sort of how such a popular Glif is made and how much care can be put into a Glif. Anyway, thank you so much for following. Feel free to remix this Glif if you would like. You can swap out your own pieces and adjust it to your own, your prompts, your IP adapter, etc., just by clicking that remix button. Thanks again, and look forward to seeing you at the next tutorial. Hi, welcome! Welcome back to our Glif tutorial series. If you are new to the series, Glif is basically a mini app builder, a Lego block style builder for generative AI. So it takes lots of different generative AI programs, language learning models, image models, and allows you to plug and play those to create these really cool interactive apps, or basically mini apps. We do have an API as well that you can then use and share with other users. So today we're actually going to explore one of the newer models in the space, Flux. But we've been hearing a lot of hype about Flux Pro and Flux Dev. I'm going to focus actually on Flux Schnell today because I think Flux Schnell is sort of like an unsung hero in the space, and I want to show you a really cool use for it. Now, all of these Flux models are really great with generating text, but I think people do overlook Schnell, which is no less competent. It's a really competent model for text. So all the text in this workflow is going to be generated by Schnell in that final creation. And schnell, for those who don't know, I'm probably not pronouncing it perfectly right, but it actually means fast in German. So here we have a prompt. I'm just going to put in a girl looking out her window in a Parisian apartment, anime style, enjoying a parade. And the great thing about this, on the street. And the great thing about this is we are actually going to see how quickly Schnell operates too. It's like almost instantaneous. We now have this basically storyboard or like sketch style comic. And as you can see, there's a lot of consistency. Maybe it's not perfect, but this is meant to be a storyboard maker. And for those who are familiar with storyboards, it's okay if they're not like exactly perfect frame to frame. It's sort of the point of storyboards. I made this because I do animation, I love animation, and I wanted an easier tool. So let's go ahead and jump in. We're going to click build to start our project. And then the first block that we're going to put in is an text input block. This is what users are going to be able to put their text descriptions of the actual comic or storyboard they want. We'll say comic in this case because it's easier for people to wrap their heads around. Next, we're going to pick a language learning or text generation block. So go ahead and grab that, and this is going to generate the story for our 4 panels and break it into panels and also format it into a JSON format. So we need to change the max tokens to 5,000 because 200 is not enough to make all that information. We're going to switch to Claude 3.5 Sonnet because it's super smart. And then we're going to give it very specific system prompt instructions. System prompt is basically how you tell the LLM, the language learning model, the job it's doing. And then the prompt is where you tell it how you want it to respond right now. So it comes in knowing what job it does, and then it jumps in and starts to respond to your regular prompts. So here we're actually giving it the exact formatting we want for the JSON. So broken up exactly like we want, because that's going to give us the best results and allow us to break this into a multifunctional tool and create these separate panels. I'm also emphasizing words like animatic because I think it really leans into like that storyboard element, and it'll give me more of that kind of like sketch style that I'm looking for. Next, we're going to do a JSON extractor. Now, the JSON extractor is going to take that JSON file that's generated by the LLM, and it is going to literally pull that information out and parse it into component pieces that we can then call in the next part. So we're going to just go through and fill these in. I do actually have a 20-panel version of this workflow. It's too much to go through right now, but I will link it in the documentation. So if you want to do a more complex version, you can absolutely remix that one. It's built the same way, just with 20 panels instead of 4. And the end, I use an HTML block. So we're then going to jump into the next part, which is the image generation. So each panel I want to have separate with each panel piece, but to keep them really consistent, I'm going to have the style be the same in each one. So we're doing the JSON panel 1 and JSON style. And that allows us to have some differences in the action, but the style the same. We're going to click Flux Schnell. I think it's perfect for this workflow. And then we are going to go ahead. 4 steps is totally fine for this as well. It does not need to be crazy, but we do want to emphasize fixing the seed, because you want the seed to be the same in all of your images. I've noticed, especially with the Flex model, the seed helps to make the super, super consistent output. It will make characters very similar. It's really like an amazingly powerful seed, which hasn't always been the case. Seeds have always been somewhat powerful, but this is like incredibly powerful. I'm still finding cool things with the Flux seeds, so to speak. And then lastly, once we have those 4 panel generations, which do include text, I want to add, it has a text prompt in it. We're going to then hop into the canvas. You can use HTML as well. The example of the 20 panel will have a version of that. But for this, I just want to keep it super simple. We're just going to do a 4 panel and we're going to use the canvas. So I'm going to make it the background gray, and then I'm going to resize it. It is a beta version of this canvas. So if you have any sort of like formatting pieces, you might just have to play with it a little bit to get it to work just the way you want it to. And then we're just going to put those squares in. So the first block here is going to be our first image. We'll size it the way we want to size it. So it's really like a nice kind of perfect size for this storyboard. Put it in that top left quadrant. And then we're going to go ahead and duplicate it so that we have the exact same size for each one. We'll switch that image to image 2. That's the second panel. And we're just going to go through and keep doing that until we have all of our panels, and just make sure they look the way you want them to. And now let's try it out. We've gone through and made the image generation, the JSON, the text generation to create our story. And now let's add a dog who learns how to speak. Really simple, sort of silly, speak English, simple, silly story. Let's see what the AI comes up with. And just to remind you, all of this text is being generated by Schnell from that, the original LLM. And as you can see, the text is pretty consistent and coherent. It's kind of a silly, weird story. It definitely has a consistency of character. Maybe not perfect, but for a tool like this, I'm pretty impressed. So I hope you really enjoyed this tutorial, and I hope it's inspired you to try out some of the different types of models that come with the Flux model. I look forward to sharing our next tutorial with you. Until then, have fun trying out Glif.
Hello, welcome back. As you might be aware, this is our tutorial series where we go into how to build glyphs. Now, for those who are new, glyphs are basically mini apps made from multiple different generative AI tools, whether those be LLMs or generative image creation, sound creation, etc., and mixing them all together to create these really cool, creative mini apps. So, in these tutorials, we sort of explain how these are made and give you ideas for ones you might want to make. And today, we're going to explore this recipe maker glyph by Ostrich, which we have remixed onto my page here. So as you can see, it's a pretty cool recipe maker in its own right. Basically, you take a recipe, anything you can think of, and it's using an LLM in the back end to come up with how that recipe should be cooked, which oftentimes is actually right, and then using an image generation model to actually make pictures of each step. So it's just 3 pictures, but it's still pretty cool, and they're all stylistically consistent, which is really great. Hopefully it inspires you actually to make some recipes too, but if not, it's just a fun glyph to make. So first, we always go into the build section. This allows us to start a new draft for a glyph. Next, you're going to go in and click your first text input. And we're only going to need 1 text input today because it's pretty simple. So here, we're just going to have people put in what they want to cook. And yeah, it's pretty straightforward. Pizza with a Glif company logo on it. Fun enough. The next step that we're going to do is set up the text generator, the LLM. And here we'll start with the prompt. This I'm actually taking from the original Glif by Ostrich. It's using that user input, and then we're asking the LLM to basically create the response. So that's why we're doing user agent. And then we will make sure there's more tokens. We need more than 200. So we'll bump it up to 3,000. And for this one, we're going to use Claude Sonnet because Claude Sonnet is pretty advanced when it comes to getting into a lot of interesting and nuanced details. And then lastly, I'm going to provide this for you. So you'll see this actually attached in the tutorial documents, but we're giving a clear outline of how the system prompt, which is how the LLM should respond. In this case, you can see it's quite descriptive. It has a JSON formatting, which is what that agent piece that we saw before will output. And then it has a little more descriptive information about how it should be described, because we don't just need the steps, we actually need the images as well. And so this allows it to parse out a JSON formatting structure, which we're going to use the JSON extractor for so that we can input into the correct spots. So let's go into that JSON extractor. First, we're going to have the text. That's the LLM output. And then we're just going to go through section by section. Luckily, there's only 3 sections, so you can just break it up into the 3 parts. We tend to, we're going to get rid of the placeholder thing. I'll keep it. We tend to try to keep the naming consistent so it's really easy for us to track what's going on, what the next step should be, etc. And we just want 3. So we have the 3 titles, one after the other. And of course, then the My Recipe title is just the overall recipe. So let's see. Lastly, second to last rather, we're going to go into the Glif block, and this is going to be where we actually generate the images from. We're calling a very particular Laura here. So this is a stylized Glif. And in this case, I'm going to actually be running Flux Coda, which is a Laura that I've trained on sort of like film styles over Flux Schnell. So it's basically running a Flux Dev Laura over Flux Schnell, which makes it like super fast at generating. It's much more conducive for a generation, and we can grab the code for that from the HTML itself. So instead of using like just the image generation block glyph, we're actually using a unique and distinct Laura glyph and running it through as though it's the image generation block. And you can see sort of how it's built in the back end. It has all the different elements, like the Hugging Face repo is something that can be swapped out, as well as the safe tensor. That's the file name of the LoRa. And then it's already calling Flux Schnell and has all of its like scheduler steps and text encoder, etc. So these are all set up for you ahead of time and something that can be easily found and created. And it's a pretty straightforward comfy UI workflow, really meant to generate a simple image with a LoRa kind of guiding that stylistic piece. So we're going to put in, when we do the Glif block, I should say, it does actually create all the different very unique and important inputs. So we're going to go through, fill the Hugging Face repo, which is connected to that Alvdonson Flux Coda. Then we're going to go into add the safe tensor name for the clip. You can do both, or you can do one and the other. In this case, I'm just combining them. And basically putting in the clip the style right now, and then putting in T5, which is the other basically text encoder. This is going to get the description. You don't have to do it that way, but some people do it that way. Some people see a difference, basically where the T5 is better at context and the clip is a little better at style. But you know, that base it on your own experience with that as well. I don't think it's make or break. And so we're going to do the same for 3 different images, because we do need to generate those 3 different step images. So go through image number 2. Now we're on image number 3, so we're just going to swap it out. We can just, like you saw a moment ago, we can just hit duplicate, no problem. And that should be good. And then now we have all of our text and our images generated, so we're going to create an HTML block. And this is going to allow us to just combine all of those extracted pieces plus the images that we had just generated. Now, to save you a little bit of a headache, we are going to go ahead and, first of all, we're going to change the width and the height. So you can see that here. And then we provided the actual HTML code block because it is a little complex. Typically, I just use Claude to generate it. And you just need to go through and make sure that all of the titles correspond with the titles of the JSON and the image outputs. And you'll be able to tell if they don't because they'll be bright red, basically. So that is the sort of complex elements of this glyph. And let's see if it works. We're going to put in the original prompt, the Beef Wellington prompt. So let it run here. And nice consistency. And there we go. It has the full recipe. It's generating just as we expected. And it's in a sort of film style, which was the goal, honestly, is to give it that sort of like filmy, rustic, almost like early 2000s Instagram influencer style. So I hope this has been fun for you. I hope it gives you ideas of what you might be able to build on Glif. And until next time, happy glyphing.